All right. So we're diving in this research paper today on Dynamo,
Okay.
which is Amazon's internal system for handling this thing called key value storage.
Right.
Now, at first glance, it might seem a little bit on the technical side, but trust me, this paper, which is from 2007, offers like a really fascinating look into some of the engineering choices that really helped make Amazon the giant it is today.
Yeah, and what's really striking about Dynamo is how it tackles a challenge that, so many companies face, and that is how to keep your systems running smoothly even when things go wrong.
Yeah.
So imagine, for example, that it's peak holiday shopping season.
Okay.
And suddenly, Amazon's website crashes.
Oh, yeah.
Even a small outage like that, could mean millions in lost sales and, just as importantly, damage that customer trust.
Yeah, ouch. No company wants that, especially, like you said, in the middle of holiday season when everybody's trying to buy stuff.
Exactly, yeah.
So how did Amazon engineers solve this always-on problem?
Well, they realized that traditional databases, while great for many things, weren't really cutting it for this particular use case.
Okay.
You see, these traditional databases prioritize something called ACD properties.
ACD.
Yeah, it stands for atomicity, consistency, isolation, and durability.
Okay.
And essentially, they focus on making sure every transaction is, perfectly executed. The data is always consistent. But the trade-off there is that they can sometimes be slower or less available, especially if there's a hiccup in the system.
So it's kind of like choosing between a super organized filing cabinet.
Okay.
Everything's in its place. It's perfect, but it's really slow to open, versus kind of a messier desk where you can kind of always find what you need quickly, even if it takes a little more effort to tidy up later.
That's a great analogy. And for a company like Amazon, where speed and availability are so important, they opted for the messier desk approach. So Dynamo prioritizes availability above everything else, They were willing to accept a slightly weaker consistency in certain failure scenarios, but they did this just to ensure that, that system was always up and running.
So this seems like a pretty bold move. Did it pay off?
Absolutely. It turned out to be a brilliant design choice, and it really aligns perfectly with Amazon's, customer-centric philosophy.
Okay.
I mean, think about it. For a customer, is it more frustrating to have a slightly delayed update in their shopping cart or to have, their entire order rejected because the system is down?
Yeah, I think I'd much rather have a little bit of a delay than a complete system failure.
Exactly.
So how does Dynamo actually achieve this always-on availability?
Right.
The paper mentioned something called consistent hashing.
Yes.
What exactly is that?
So consistent hashing is this clever way to distribute data across multiple servers.
Okay.
Imagine a circular table with seats representing, those servers.
Right.
Each piece of data is assigned a key and gets placed on the table based on where that key falls on the circle.
So I'm picturing a giant spinning lazy Susan with, data packets instead of snacks.
Exactly. And as more servers are added or removed, the data automatically redistributes itself around the table, ensuring that no single server is, overloaded.
Okay, I like it.
But there's another layer to this, and it's virtual nodes.
Virtual nodes, what are those?
Okay, so think of it like this. Each server doesn't just occupy, one seat at that table.
Okay.
Instead, it pretends to have multiple seats, spreading its data and processing power across the virtual nodes that it controls.
So it's like one server is doing the work of many.
Exactly. That's a great way to put it.
That sounds pretty efficient.
And this way, if one server goes down, its virtual nodes' data and responsibilities are seamlessly taken over by other servers.
Oh, wow.
And the system remains stable and users experience, minimal disruption.
That's impressive. But what about larger scale failures? So what if an entire data center goes offline?
Yeah.
Surely that would cause some major problems.
Well, that's where Dynamo's replication strategy comes in.
Okay.
The system doesn't just duplicate data across multiple servers within a data center. It also replicates it across multiple data centers.
Wait, so even if, like, a natural disaster takes out an entire facility,
right,
the data is safe and the system just keeps running?
Precisely. And the paper, it gets into the nitty-gritty of how this all works. They have these parameters, N, R, and W, which allow engineers to fine-tune the balance between, durability and availability based on the specific needs of the application.
So like a customizable safety net for their data.
Yeah, you can think of it that way.
And what about those hints you mentioned earlier? Like, is that like a digital message in a bottle?
Exactly. It's called hinted handoff. So if one server is temporarily down, other servers store its data with a hint attached, indicating, where the data should eventually go when that server comes back online. It's a clever way to handle those temporary outages without losing any information.
This all sounds incredibly complex. How do they even keep track of all these, data copies and make sure they're all consistent?
Well, that's where something called Merkle trees comes into play.
Merkle trees.
Yes. Essentially, they are a super efficient way to compare data sets and detect any discrepancies. Imagine trying to spot a single spelling mistake in two, massive books. Merkle trees make that process lightning fast.
Wow. Okay, so they have this, intricate system for replicating data and keeping it all consistent.
Right.
But what happens when you have multiple users trying to update the same piece of data at the same time?
Yes.
How does Dynamo handle those conflicts?
That's a great question. And it leads us to another really fascinating aspect of Dynamo. Its approach to, versioning and conflict resolution. The system actually allows multiple versions of an object to exist.
Okay.
And it uses something called vector clocks to track their relationships, like a family tree, but for data.
So it's like keeping a detailed changelog of, who made what changes and when.
Exactly. If the system can't automatically resolve any conflicts, the application itself steps in to, intelligently merge those changes. So imagine two people adding different items to the same shopping cart. Dynamo ensures that nothing gets lost.
So even in the face of conflicting updates, Dynamo prioritizes preserving all the changes.
Yeah.
That's pretty neat.
And surprisingly, the paper actually mentions that in a real-world setting, conflicts are relatively rare.
Okay.
Dynamo does a fantastic job at keeping things running smoothly, even with tons of concurrent updates happening all the time.
Okay, so we've covered how Dynamo ensures this high availability and how it handles conflicts. But knowing Amazon's focus on speed, I bet they didn't stop there.
Yeah.
What other tricks do they use to optimize performance?
Oh, there are a few.
Okay. Yeah, you're absolutely right. Amazon, they're kind of obsessed with performance, especially at those high percentiles like the 99.9th, the 99.99th. They want to make sure that everybody has a lightning fast experience, not just, the average user.
Yeah, absolutely. And the paper highlights a couple of pretty interesting performance tweaks they made.
Okay.
And one of them is the use of a write buffer.
So instead of immediately writing every single change to disk,
Yeah.
they sort of temporarily store those writes in memory.
Precisely. It's a clever trade-off, They get a big performance boost without sacrificing, too much on the durability side. Think of it like jotting down notes on a scratch pad before, transferring them to a more permanent notebook.
Yeah, okay, makes sense.
Mm-hmm.
Any other performance hacks they talk about?
Yeah, they also mention a shift to client-driven coordination for even faster reads.
So the clients themselves become smarter and do some of the heavy lifting, taking some load off of the Dynamo servers.
Precisely. It's a great example of how they kind of distribute responsibility across the system to optimize performance.
Okay.
The clients can figure out where to find the data they need, reducing the burden on the Dynamo servers.
That's really cool.
Yeah.
The paper also dives into their kind of journey of figuring out the best way to partition data.
Right.
Which is, how to divide and distribute it across all these servers.
Yes.
And it sounds like they went through a few different approaches before finding the one that worked best.
Yeah, you're right. It was a journey.
What kind of issues did they run into?
Well, they started with a pretty simple approach, right? Assigning random tokens to each server and then dividing the data based on those tokens.
Mm-hmm.
But they quickly ran into some issues.
Like what?
Well, whenever they would add a new server to the system, right, it had to sort of steal some of its data storage space from other servers.
Okay.
And to do that, those other servers had to scan their entire storage, which is a very, resource-intensive operation. Imagine having to reorganize your entire library just to make space for like one new shelf.
Yeah, that sounds like a logistical nightmare.
Especially if you're trying to, run a massive e-commerce platform at the same time.
Right.
So they needed a more, elegant and scalable solution.
So what do they try next?
Well, they experimented with a couple of different strategies.
All right.
One involved, dividing the hash space into equal size chunks and assigning, random tokens to each server. But that approach led to some, load balancing problems.
I see. So because if the random tokens ended up clustered together, some servers would be overloaded while others would be sitting there idle.
Exactly. So they kept iterating, right? And they eventually landed on this strategy where the hash space is still divided into equal sized chunks.
Okay.
But the number of tokens assigned to each server is, carefully controlled.
So they found a way to kind of balance things out more effectively.
Precisely. This new approach had a ton of advantages. Faster server onboarding, easier backups, and of course, much better load balancing.
Wow, it's amazing to see how much thought and effort went into designing this system. It sounds like they really thought of everything. High availability, conflict resolution, performance optimization, and even efficient data partitioning.
Yeah, absolutely. It's a real testament to Amazon's, engineering culture
Yeah.
and their obsession with solving these real-world problems at scale. They didn't just build a system that worked. They built a system that could, evolve and scale to meet the demands of their, rapidly growing business.
No, I have to ask. This research paper was published in 2007, which is almost 20 years ago. How much do you think Dynamo has changed since then?
That's a great question. I think the core principles are probably still there,
Yeah.
but I'm sure they've made, significant advancements over the years. They might have even developed, entirely new systems based on the lessons they learned from Dynamo.
Yeah.
Fascinating to think about.
It really is.
Yeah.
But even in its original form, Dynamo is such a powerful example of pragmatic engineering. And it's had such a profound impact on how we build and operate, large-scale systems today.
I completely agree. And, it's also a great reminder that perfect consistency isn't always the ultimate goal.
Right.
Embracing eventual consistency, like Dynamo does, can unlock these incredible levels of availability and performance.
So it's kind of like accepting that a little bit of, temporary inconsistency is okay.
Right.
As long as the system as a whole is always available and responsive.
Exactly.
Especially in like a fast-paced environment like e-commerce.
Yeah, it's all about making the right trade-offs for your specific needs.
Right.
Mm-hmm.
This deep dive into Dynamo has been incredibly insightful.
Yeah, it's been fun.
But before we wrap up, I want to make sure we bring it back to our listener for a second.
Okay.
Why should they care about this system that was built almost 2 decades ago?
That's a great point. I think Dynamo's story is a fantastic example of how smart engineering choices can have like a ripple effect across the entire tech industry.
Mm-hmm.
The principles they pioneered, prioritizing availability, embracing eventual consistency, focusing on performance at scale. These are all ideas that have influenced countless other systems and applications.
So even if you're not, building the next Amazon, understanding these principles can help you design better, more resilient systems.
Exactly. And it's also a reminder that, innovation often comes from solving real-world problems.
Right.
Dynamo wasn't built in a vacuum.
Right.
It was built to address those very specific challenges of running a massive e-commerce platform.
It's inspiring to see how they took those challenges head on and came up with, such a groundbreaking solution.
Absolutely. Dynamo is a reminder that with, creativity, ingenuity, and a laser focus on the user experience, we can really build incredible things.
Well said.
Yeah.
Now, before we go, I did want to touch on one more point from the paper that I found particularly intriguing. They mentioned this concept of divergent versions.
Yeah, yes.
Yeah.
Even with Dynamo's sophisticated, conflict resolution mechanisms, there are these rare instances where multiple versions of the same data might, persist.
Which sounds like it could cause some problems.
Yeah.
Right? But the paper suggests those situations are actually, like, way less common than you might think.
Yeah.
They shared some data showing that, divergent versions are pretty rare in a real-world production environment.
Right.
And, when they do happen, Dynamo's designed to handle them, gracefully.
Right. If the system can't automatically reconcile the differences, the application can step in and merge those divergent versions, ensuring that, no data is lost.
So it's like having this safety net for those, rare oops moments.
Yeah, exactly.
It sounds like they really put a lot of thought into making Dynamo as robust as possible.
So they definitely did. And, it's fascinating to think about all that behind-the-scenes complexity that goes into making something like Amazon's website seem so, seamless.
Seamless and effortless to us as users.
Right. It's a good reminder that there's like a lot of incredible engineering happening behind the scenes of, our everyday digital experiences.
Yeah, I couldn't agree more. Now, we've been talking a lot about how Dynamo handles failures and ensures, high availability, which is obviously crucial.
Right.
But there's another, equally important aspect of its design that we shouldn't overlook.
What's that?
Well, remember that Dynamo was built to support, Amazon's massive e-commerce platform.
Right.
A system that handles millions of customers browsing, buying, selling products, all at the same time.
Right, so it's not just about, like, staying online.
Yeah.
It also has to be incredibly efficient and performant,
Yes.
just to keep up with that kind of demand.
Exactly. And that efficiency is kind of baked into every aspect of Dynamo's design, from its simple key value interface to its clever use of, consistent hashing and virtual nodes.
They really squeezed every ounce of performance out of the hardware.
It's like they designed it to be this like lean, mean data handling machine.
That's a great way to put it. And of course, they designed it to be incredibly scalable too.
Mm.
As Amazon's business grew,
Right.
Dynamo needed to grow with it.
Mhm.
Seamlessly handling, ever increasing amounts of data and traffic.
That's remarkable. This research paper really gives us like a peek behind the curtain of, one of the most successful companies in the world.
Yeah.
And it's inspiring to see how they, tackle these challenges and built a system that's not just robust,
Right.
but also like incredibly efficient and adaptable.
I agree. And, the lessons learned from Dynamo have had a huge influence on, countless other systems and applications. Its principles are still relevant and valuable today, even as, technology continues to evolve at such a rapid pace.
So what's like the main takeaway you want to leave our listener with today?
I think Dynamo's story is a really powerful reminder that, great engineering is about more than just writing code.
Yeah.
It's about, deeply understanding the problem you're trying to solve, making those smart design choices, and always, prioritizing that user experience.
That's a great point. And sometimes that means being willing to, challenge the conventional wisdom.
Yeah.
Like, prioritizing availability over strict consistency.
Exactly. Dynamo's success is a testament to the power of, creative, pragmatic engineering.
Well, there you have it. A deep dive into Dynamo, Amazon's, secret weapon for building this highly available, scalable, and performant e-commerce platform. We've explored its key design principles,
Right.
its, ingenious optimizations, and its lasting impact on the world of technology.
And we've seen how, Amazon's commitment to customer obsession and operational excellence, really drove the creation of this, groundbreaking system.
It's a story that's sure to inspire anyone who's, passionate about building the next generation of world-changing applications. Thanks for joining us on this journey, and we hope you'll come back for more deep dives into the fascinating world of technology.
Until next time, keep learning, keep exploring, and keep pushing the boundaries of what's possible.